Section 3.1, Complex Numbers. In this section, we'll express square roots of negative numbers as multiples of the number I, plot complex numbers on the complex plane, add and subtract complex numbers, and finally multiply and divide complex numbers. And I think even though the title says complex, I think you're going to find this section extremely easy. So the first thing we want to do is introduce you to the number I. So the number I is equal to the square root of -1. So that's the definition of the number I. And so I is an imaginary, that's why we use the letter I, an imaginary number. So up until now, we've been talking about the real numbers, and we've always said we can't take the square root of a negative number because we don't have any number that we could square and get a negative. And so mathematicians developed the number I. And so the number I is literally the square root of -1. So since I is equal to the square root of -1, I squared is -1. And so complex numbers are an example of 6 plus 5i. So complex numbers have a real part and an imaginary part. So other examples of complex numbers would be something like -4 plus 5i, 3 minus 2i. Those are all examples of complex numbers. Now, a complex number can be of the form, let's do it the other direction first. It can be of the form, for example, of 5 plus 0i, or in other words, 5. We can think of the number 5 as a complex number. We might just say, oh, it has 0i for the complex part. Or if we see something like 3i, that's also a complex number because we could write that as 0 plus 3i. If we see a number of the form 3i, for example, we often call that a pure imaginary number. Because it only has an imaginary part, not a real part. You can plot complex numbers on what's called the complex plane, and this is very easy to do. We think of our traditional axis system. And the horizontal axis is where we would graph the real number part of the complex number, and the vertical axis is where we would graph the complex part, or the imaginary part, of the complex number. So for example, suppose we wanted to graph this complex number, 3 plus 4i, in the complex plane. The real part is 3, and the complex part, or the imaginary part, is 4. And so this would be the location of 3 plus 4i. Let's see if we could graph -4 plus 5i. Again, -4, so the real part would be at -4, and the imaginary part would be at +5. So this would be the point -4 plus 5i. And that's all there is to graphing complex numbers in the complex plane. Adding and subtracting complex numbers is really easy also. It works just the way that you hope it was. You add the real parts together and you add the imaginary parts together. So 3 plus 2i plus 4 minus 6i. If we combine the real parts, we get 7. And if we combine the imaginary parts, we get -4i. With subtracting, the only thing you have to be careful of is distributing the negative number. So 5 minus 2i minus 4 minus 3i. Let's show the details of that. We're going to remember to distribute the negative sign. And then we simply combine the real parts and then combine the imaginary parts to get our final answer. And so here's one for you to try. See if you can do 7 plus 2i minus 1 minus 4i. And don't forget, distribute the negative sign. Multiplying complex numbers is also quite easy. All you have to remember is that I squared is equal to -1. So whenever you see an I squared term, you'll just replace that with -1. For example, here we'll distribute. So 3 times 2 plus 5i would be 6 plus 15i. 5 plus 2i times 3 minus 4i, we're going to distribute. Or if you wanted to use FOIL, you could. Same thing. If we distribute the 5, we get 15 minus 20i. And now we will distribute the 2i. That would give us 6i minus 8. I times I is I squared. And so when we multiply, we have to remember that I squared is the same as -1. And so I'm just going to write down all the details here. We have 15 minus 20i. So 15 minus 20i plus 6i. And here we have -8 times -1. And this is going to be a positive 8. So we have 15 plus 8. That's going to be 23. And if we combine our imaginary parts, we're going to have minus 14i. Let's do one more. We're going to distribute. First, we'll get 18i plus 12i squared. And again, the only thing we have to remember is whenever we see an I squared term, we're going to replace that with -1. So that gives us 18i. 12 times -1 is minus 12. Usually, when you write a complex number, you write the real part first, followed by the imaginary part. It's not wrong to leave it as 18i minus 12, but traditionally, you'll just always see the real part written first and the imaginary part written second. Okay. Now, the next thing and the last thing we need to do is to divide. But before we can divide, we have to talk about something called conjugates. So conjugates are pairs of complex numbers which have the same term but a different sign between them. So for example, 2 plus 3i, its conjugate would be 2 minus 3i. 4 minus 6i, its conjugate would be 4 plus 6i. One more. 2 minus I, its conjugate would be 2 plus I. And multiplying conjugates together always results in a real number with no imaginary part. Let's multiply a pair of these together so we can see that. So let's take this last pair here, and we're going to multiply them together, and we're going to see that our result is going to be a real number with no imaginary parts. So 2 minus I times 2 plus I, we will distribute. We're going to have 4 plus 2i, distributing again, minus 2i minus I squared. Now remember, whenever we see an I squared, we're going to replace that with -1. And notice that the 2i and the -2i will cancel. That will always happen when you have conjugates. So we're going to be left with 4 minus -1, or in other words, 5. We multiplied two conjugates together, and see, we got a real part, a real number, with no imaginary part. So why don't you see what you get if you multiply these conjugates together? So go ahead and multiply 2 plus 3i times 2 minus 3i and see what you get for an answer. And the reason we stopped and looked at conjugates was because we use conjugates when we divide complex numbers. So when you divide complex numbers, you multiply by the conjugate of the denominator to make the denominator into a real number. So for example, suppose we had something like 3 divided by 2 plus I. What we're going to do is we're going to multiply the numerator and denominator by the conjugate of the denominator. That'll look like this. 2 minus I, and we'll multiply the top by 2 minus I. Now on top, when we distribute, we're going to get 6 minus 3I. In the bottom, when we do this, we're going to have 4. Remember that we're going to get a minus 2I and a plus 2I. That's going to cancel. Minus I times I, which is I squared. In other words, 4 minus negative 1, or 5. Now you might say to yourself, how does this answer look any better than what we started with? Well, that's a good question. Traditionally, we always write imaginary parts in the numerator and not in the denominator when we can. And so we started with an imaginary part in the denominator. Our answer, notice, has no imaginary part in the denominator. Let's try one more. Suppose we had something like 4 plus 5I divided by 2 minus 3I. Now remember, you don't care about the numerator. You only want to multiply by the conjugate of the denominator. So the conjugate of the denominator is 2 plus 3I. So we'll multiply the numerator and denominator by 2 plus 3I. Now notice on top, it's going to be messy. Let's go over here and do that. 4 plus 5I times 2 plus 3I. If we distribute, we're going to have 8 plus 12I. Then we're going to have plus 10I plus 15I squared. We'll remember that whenever we see an I squared, this is going to be equal to negative 1. So what we have so far now is 8. Combining our i's, plus 22I. 15 times negative 1 is negative 15. And if we combine those, we have negative 7 plus 22I. So that's our new numerator, negative 7 plus 22I. But in the denominator, because these are conjugates, when we multiply them together, we should get a real number with no imaginary part. So let's give that a try. 2 times 2 is 4. Then we're going to get 6I and negative 6I. Notice those are going to cancel. And then finally, we're going to have negative 9I squared. We're going to remember that I squared is the same as negative 1. And so what we're going to have is 4. The i's will cancel. A negative 9 times a negative 1 is a positive 9. So our new denominator is 13. And notice, no imaginary part in the denominator. So complex numbers are pretty easy. All you have to remember is whenever you see an I squared, it's equal to negative 1. So here are 3 for you to try: a subtraction, a multiplication, and a division.